Now question number 81. The correct order of delta naught for the given complexes is. It means we just have to find out that option in which correctly these complexes are arranged on the basis of their decreasing value of delta naught. Let's consider the complexes given here. In all of these complexes, certain ligands are present, and we should know that this delta naught value depends on ligand field strength. More the ligand field strength, more would be the value of delta naught for that particular complex. So in this case, we have three ligands. One is ammonia, this NH3. The second is H2O, and then third is NO2. And the correct order of their ligand field strength is, I'm just arranging them. NO2 has the maximum ligand field strength. Then after that, there is ammonia, NH3, and after that, H2O. This is the order. And on the basis of this order, we can find out the correct order of this delta naught value. It means the complex with this ligand has the maximum ligand field strength, and that is here given in option 3. Further, there should be the complex in which ammonia is present as the ligand, the second complex, and third is H2O as the ligand which is present in this complex. So only option 3 is showing this correct order of the ligand field strength. It means it is also following the correct order of delta naught value also. And that's why I'm just choosing this as the correct answer. This is option 3. Question number 82. The number of unpaired electrons in the given complex ion is. In this case, the ion is Fe H2O6 hexaaqua iron. This is the ion that's present here, and in this ion, iron is present as Fe2+. This is the oxidation state of this iron. And if we write the electronic configuration for Fe2+, this is 3d6 4s0. And if we talk about this H2O, this is a weak field ligand. It will not cause pairing in d orbital. It means this can be represented as 6 electrons, 1, 2, 3, 4, 5 and 6. Now these are unpaired electron, and further it will result in the formation of outer spin complex. It means in this case the total number of unpaired electrons would be 4, and on the basis of this the correct answer is option 4. Question number 83. Aqueous solution of which species shows highest molar conductivity? Molar conductivity can be identified with the help of the number of ions. More the number of ions are present in the solution, more would be the molar conductivity. So if I talk about the first complex, that is K3COC2O4 3. How many ions are there? 3 potassium ion and 1 complex ion is there. It means in this case there are 5 ions, 1 complex ion and 4 Br negative ions. Now in the third option we have the complex in which 1 complex ion is there and 1 chloride ion is there. It means total 2 ions can be formed in this aqueous solution. Further another complex is there, but in this case there is no ion, 0 ions are there. Now just identify the compound with maximum molar conductivity. That is given here in option 2, because in this case there are total 5 ions which are present. That's why I'll choose it as the correct option for this particular case. After this, the question number 84, the complex which does not follow EAN rule is. We have different complexes given here and we need to just find out that complex which does not follow EAN rule. What is that EAN rule? The EAN value can be calculated by using the simple formula. What's that? That is atomic number of central metal minus the number of electron lost, or simply you can say the oxidation state of the metal in that particular complex. So number of electron lost we can write here, and then just add here the next thing. What's that? That is number of electrons gained. From where this complex is gaining number of electrons? from the ligand only. So for the first complex, suppose I'm talking about NiCO4, nickel carbonyl we're talking about. This is the complex. In this complex, the atomic number of this nickel is 28. Ni is present in 0 oxidation number. So there is no electron that is lost. So it's 0 plus CO4 and total 8 electrons it is gaining from the carbonyl ligand. CO ligand, carbon monoxide ligand. So it would be 36. And for the 3D series, effective atomic number should be 36, and that's why this 36 is here. It means it is following this EAN. Further, if I talk about the next complex, that second one, it is CO NH3 6 Cl3. In this complex, the central metal is cobalt with atomic number 27. It is present here in 3 plus oxidation state. You can calculate easily. So minus 3 plus how many electrons it is gaining from ligand? It is gaining 6 to the 12. 12 electrons it is gaining. That's why it becomes 36 once again. And it is also following EAN further. Next complex is K3 FeCN6. This is the complex, and in this case, iron is a central metal atom and its atomic number is 26 minus the oxidation number of iron. In this complex, the oxidation number of iron, if you calculate, you will find it is 3. Further, number of electrons gained. 6 ligands are there, so total number of electrons 12. Here it is 35, and if it is 35, it means it is not following EAN. Now let's check the next compound also. The next complex that's given here is K2ZnOH4, and in this case potassium is present, zinc is present, but the central atom is zinc here and its atomic number is 30 minus oxidation number of zinc in this complex is plus 2. So 2 electrons it is losing. Further, 4 ligands are there, OH is the ligand, so total 8 electrons it is gaining. So 28 plus 8, it becomes 36 once again. And if it is 36, it is following the EAN rule. Only one complex is not following EAN rule, and that is given here in option 3. And that's why the correct answer is option 3. Question number 85. The most acidic oxide among the following is. All of these are the oxides of manganese. We need to just identify the most acidic oxide of manganese. We should always know that the oxide in which element is present in higher oxidation state is more acidic. So we have to just identify the oxidation state of manganese in all of these oxides. In first case, manganese is there in +2 oxidation state, while in the second case, if you look at this Mn2O3, in this case manganese is there in +4 oxidation state, while in Mn3O4 the oxidation state of Mn is there, that is 8/3. While if we talk about Mn2O7, in this case the oxidation of manganese is +7. So in which complex manganese has the maximum oxidation state? Definitely it is here in option 4. This oxide Mn2O7 is most acidic oxide because the oxidation number of manganese is maximum in this case, and that's why option 4 is the correct one. After this,